Find the tangent line to the equation f of x equal to x of sine inverse of x over 2, the point x equal to 1. Once you've found the tangent line, use it to approximate f at 1.1. So to start, I immediately write down the equation of a line when we're given a point and a slope. Here, the slope is just going to be the derivative of f evaluated at x0, which in our case is 1. And I'm going to need x0 and y0. x0 is 1, y0 is what I'm going to get if I put 1 into my function. So we follow our nose, and I'm looking at inverse sine of 1/2. If you don't have that off the top of your head, let's see how we get that. So to start, we note for inverse sine, these values, which are angles, are going to go from minus pi halves all the way up to pi halves. To figure out what angle we use, I'm going to use a little language trick I call the sine inverse 1/2 equal to theta. We name it theta. And then I can move the sine to the other side, giving me sine of theta equals 1/2. Now, from trig, we know the 1/2 value goes with either pi thirds or pi sixths. So I just need to decide which one. Well, the other number that goes with 1/2 is square root of 3 over 2. That's roughly 0.87. So what we're looking at here is sine represents y values in the unit circle. So I want to know I have y equal to 1/2. Which angle goes with that? Pi thirds or pi sixths? Well, 1/2 is less than 0.87, so we're looking for the angle that has the smaller y value. That's going to be pi over 6, since that's a shorter angle. That means our point is 1 comma pi over 6. Now let's take the derivative. I'm going to use a product rule and then a chain rule. So for the derivative of the first, we get 1, multiplied by the second, plus the first times the derivative of the second. So here, remember, our rule is I'm going to take 1 over radical 1 minus u squared, then times the derivative of u. So we just pretend I have all the u stuff in a box, so that's my u prime, radical 1 minus u squared. My u is going to be x over 2, so I put it in each box, and then we take the derivative of what's in the box, which gives me 1/2. We could try to clean this up, but why bother? I only care about it at the point 1, so I'm just going to stick 1 in and see what comes out. I'm going to get sine inverse of 1/2 plus 1/2 up top times 1 over, well, let's see, we have 1 minus 1/2 squared. That's 1/4. 1 minus, it's 3/4. We're going to radical that. I could bring the 2 in as 4. Just to bring it into a square root, I have to square it. So that's going to give me 1 over radical 3 here. So our slope is pi 6 plus 1 over radical 3. We go to the tangent line. So the equation says y minus pi 6 equals pi 6 plus 1 over radical 3, x minus 1. So that's the tangent line. But when I approximate at 1.1, I just stick 1.1 in for x. That gives me, pushing the pi 6 to the other side, pi 6 plus pi 6 plus 1 over radical 3 times 0.1. Going to my calculator, that's going to give me 0.634. If I want the actual value, I'm just going to stick 1.1 into the original function. Okay, that's actually f. And that's going to give me my x, which is 1.1, sine inverse of 1.1 over 2. Remember, when we go to the calculator, this is going to be radians, so make sure you're not doing it in degrees. And that's going to be, when I figure all this out, 0.640. So we see that we're in the ballpark using the tangent line to approximate.